Okay, so today we're going to start talking about keeping food safe throughout our operation. We're going to call that the flow of food. Starts at purchasing the food and then receiving, storing, prepping, cooking, cooling if we have to, reheating, and finally serving. So today we're going to have an overview, and then the next couple of classes we'll go through each one of those steps. Okay, so keeping safe food throughout that flow, the two things that we have to focus on are preventing cross-contamination and time temperature abuse. So we look at cross-contamination. Want to make sure that we're using separate equipment. We have different colored cutting boards that we use in kitchens for different items. So poultry would go on a yellow cutting board, raw poultry would go on a yellow cutting board. Fruits and vegetables would go on a green cutting board. And then there's a whole range of others. Cooked meat goes onto a brown cutting board. Then we want to make sure that we clean and sanitize everything so there's not a chance that we are going to use contaminated equipment. We want to prep our ready-to-eat foods at different times than we do our TCS foods. So if we're using, we only have one prep table, make sure that we have our fish, meat, poultry prepped at a separate time than we have ready-to-eat food. Ideally, you would do your ready-to-eat food first, get it put away, and then do your meat, seafood, and poultry. Okay. Another way to prevent cross-contamination, prep raw. Yeah, same thing. Want to keep the meat separate, but also look at buying prepared food. And I know we went through the review on Friday, and it asked this question, and this is what they're talking about. Buy the things that are already processed and packaged, and that way you reduce the chance that you're going to get it contaminated with something else that you have in your kitchen. Time and temperature control. The temperature danger zone, 41 degrees to 135 degrees. So if you have food in that temperature danger zone, then the bacteria, viruses are going to grow more quickly than they do at refrigerator or at oven temperatures. So food is being temperature abused when it's handled in the following ways. Cooked to the wrong internal temperature. It's held at the wrong temperature. When we're talking about holding food, it could be, we have the food out on a buffet and the containers that we have in isn't keeping it hot enough or cold enough. It could be something that was left out in the kitchen overnight that should have gone into the refrigerator. Could be that our refrigerator went down and the food all went above 41 degrees. Next thing is it's cooked or reheated incorrectly. That anything that's supposed to be cooled or reheated incorrectly, because we're going to learn processes for cooling food and for reheating food. And then this is going to be very important. Most of our pathogens grow much faster between 70 degrees and 125 degrees Fahrenheit. If you've been in a hospital or visited somebody in a hospital recently, the patient rooms are really cold because they're set under 70 degrees, because that helps to reduce the growth pathogens. So to avoid time and temperature abuse, we're going to keep track of temperatures. So we're going to take temperatures, make sure we have the correct kinds of thermometers available. We'll talk about the different thermometers. Regularly record temperatures and the times that they are taking. Minimize time food spends in the temperature danger zone. Take corrective actions if time temperature standards are not met. So we take a look at our first type of thermometer. Book called for the bimetallic stemmed thermometer. Oftentimes we'll call it an instant read thermometer, even though it's not instant. The different components. The top, there's an indicator head. This is an analog, like the clock on the wall. It could be digital. The advantage to analog is that they're a lot easier to calibrate. We're going to talk about calibrating them. There's a little nut here that helps us in the calibration process. The whole thing is the stem. The dimple is a couple of inches from the bottom, which is pointed, and that's the entire area is our sensing area. So when we use this thermometer, we're using it in something that you can insert that 2-inch part of the probe into. Okay. Other types of thermometers, thermocouples and thermistors. These are digital, they're battery operated, and they have several different probes that can be plugged into them. So all of those probes are made of metal, digital. The sensing area is at the tip of the probe. And the different types of probe are an immersion probe, which is what's seen in the picture here. That's going into a liquid. A surface probe would be to take the temperature of a grill or a skillet or some type of a stovetop. Penetration probe is for something that's more solid than the immersion probe. So like a roast or a turkey, if you put the penetration probe, and then the air probe is to take air temperatures. Okay, so the air probe has little circles in the ends of it where there's different sensors. And then this is a surface probe where you actually put it onto the surface. We know what the penetration probe looks like. We also have infrared thermometers. If you were a student here 12 months ago, you would have seen one every day when you came to the building. It would take your temperature. If you went anywhere, you had to get your temperature taken. You want to hold these close to the food or equipment as possible. Take away anything that is like blocking the actual food. Follow manufacturer's guidelines. Each one has a little bit different setup. There's also something called a maximum registering thermometer. It indicates the highest temperature reached during use. So we use these in places where you cannot continuously observe the temperature. So what we have in the photograph is a dish rack that's going through a dishwasher. And this particular dishwasher is going to be long with conveyor belt. You're not going to be able to get into the final rinse area. And that rinse water has to be a certain temperature in order to sanitize the dishes that are going through it. So that's what this type of a thermometer is. It's going to register the highest temperature so that you know that your dishes are being sanitized with hot water. There's also time temperature indicators. They monitor time and temperature. This is something that the purveyors, the sellers, will put on a case before it's delivered to you. And then you can see if it goes into the temperature danger zone for a long period of time. So they put it on and activate it. The little on sign comes on, and then there's a timer, the timer and the temperature indicator. So when they color in, that tells you that your food has been time temperature abused. Okay, so calibrating thermometers, it's going to be adjusting the thermometer in order to get a correct temperature. So you want to have a true temperature so you know your food is properly cooked or that your coolers are working. We have two methods that we use, an ice point method and a boiling point method. The boiling point method, you just take water and put it into a pan and bring it to a boil. You put the thermometer stem or probe into the water. And the red thing you see is the case that comes for the thermometer. And that casing has a place to hold the calibration nut in place so that you can do things like hold it over boiling water without steaming your hand. And then the last step would be in boiling water. It should be 212 degrees Fahrenheit. So you're just going to rotate the top of the thermometer until it reaches 212 degrees. And then with the ice point method, we'll fill up a container with ice. We add some cold tap water to it. Put the thermometer into it, same way. You can see a little bit better here how the thermometer sits into the casing. Probably have to wait at least 30 seconds for the temperature to set. And that temperature should read 32 degrees Fahrenheit. So we're looking at the freezing point of water and the boiling point of water, which we should know. So we calibrate these things pretty much on a daily basis, or if you drop it during the day, or if you put it into something very cold and then shortly afterward put it into something very hot, it can tend to lose its calibration. Want to make sure that we wash, rinse, sanitize, and air dry them both before and after we use the thermometers. Calibrate them after they're bumped or dropped in temperatures. Before deliveries arrive. Next chapter, we're going to be talking about receiving food, and certain foods have to be certain temperatures whenever we receive them, so we need a good, accurate thermometer. Okay, so when we're using them, we have to make sure that they're accurate. So we have to buy a thermometer with a certain degree of accuracy. So checking food, they have to be accurate within plus or minus 2 degrees Fahrenheit. And the manufacturer is going to tell you that that is the accuracy of the thermometer. If it's an air temperature thermometer, it's used to plus or minus 3 degrees Fahrenheit. The only time we can use glass thermometers in the kitchen is if it's enclosed in a shatterproof casing. Glass thermometers are used usually for when you're boiling sugar in a pastry kitchen. You need to make some type of a syrup, and different stages of syrup have different temperatures. And that's the only time that we should see a glass thermometer, but it is enclosed in a shatterproof casing. Okay, typically we insert the thermometer stem or probe into the thickest part of the food. So if we have a roast, not often that it's uniform in shape, so you want to check the thickest part of it first. Take more than one reading in different spots, especially with something like a turkey. What you're going to learn is like most ovens have hot spots and cold spots. So things might need to be rotated during cooking so that they get evenly cooked. And give time for the thermometer reading to steady. What it won't do, like if you have a room temperature thermometer and you stick it into a roast, it's not going to go back and forth. It's going to go up and keep going up and then finally stop. So if it does pass the temperature that you want it to get to, you don't have to sit there and wait until it's further past. Okay, that is everything for chapter 4. Any questions on that or any of the quizzes that we've had so far? Okay, we'll continue on then on Wednesday.